because since the heading is not given in the question, you have no other choice but to assume a heading. Alright, let's do the question together. An aircraft is flying a heading with 12 degrees starboard drift, making good a track of 5 nautical miles left of center line, but parallel to it. Find the relative bearing of NDB situated at the center line of the airway 300 nautical miles ahead. You see, 30 nautical miles ahead. You see, the airways can be defined by NDBs. We have seen it before. So the airway is basically defined by a particular NDB. So in this case, to start drawing, as I've told you before, I need a track. That is, the track is the one with which I can draw something here. So here this question, what they have given us, the aircraft is flying a particular heading. The heading is not mentioned at all. But what they have told is there is 12 degrees of starboard drift. Right? Remember, with the 12 degrees of starboard drift is not derived from the ADF. So in the previous question we saw what the ADF indication was 186. So you derived the drift from the ADF indication as 6 degrees starboard, and therefore the derived drift is an actual drift. But in this case, in this question, the drift is given directly in the question. It is not read from an ADF reading, and therefore that drift is not an actual drift. You have to take that 12 degrees starboard drift as a planned drift. So here we have a planned drift, which is right here. Planned drift of 12 degrees starboard. Now to draw the track, we need the heading. Just with the drift, you cannot draw a track. So in this question, the heading is not given, and for that reason, as you said, we have to assume a heading. We'll close now. We can come back when we close. So let's assume a heading. That's the first catch here. So assume a heading. So if you want, you can follow me through with a different heading, or probably you can use the same heading. I'll take a very easy heading for now. Take, for example, 270 degrees magnetic is the heading. Now, when I take the heading of the aircraft as 270, immediately I can apply this drift here. But remember, this is a planned drift. Therefore, the track which you're going to get is not the actual track. It's going to be the planned track, because you're deriving it from the planned drift. Right? So what's the planned drift? Planned drift is 12 degrees starboard. So what is the track? Track is 12 degrees starboard of heading. Therefore 270, yes, 270 plus 12, 282 degrees. And remember, that is a planned track. I hope you understood why it's a planned track, because it's derived from the planned drift. Right? In the previous question, just go back to the previous question and see that the drift given there from 186 degree ADF indication, we derived the drift to be 6 degrees starboard, and therefore the track which you obtain from that drift is going to be the actual track, because of the actual drift. But a drift that is given straight in the question like this, not derived from an ADF reading, is always a planned drift, and therefore from the heading, whatever you get is a planned track, and that is 282 degrees. Now we have something to start with, because we have a track now. Let's draw a track of 282 degrees. This is a track of 282 degrees, will be somewhat in this direction, and make a note that this is the planned track, not the track made good. What all can you find on the planned track?
Planned track, planned drift.
No, the points on the ground that you can find on the planned track is your departure station, your destination station. It's all on the planned track. But where will you find the aircraft? The aircraft can be only found on the actual track. So if I want to draw the aircraft here, I have to first find out the actual track. In the previous question, I could draw the aircraft straight because what I initially got itself was the actual track. But then I couldn't locate the destination because I didn't have the planned track. Here I have the planned track as 282. Let's see, let's divide this track into two, and let's draw the NDB here. The NDB. Now, where will you place the aircraft? On which side? You cannot place the aircraft on this, but if at all you want to place it, will you place it on the left or the right?
On the right.
On the right. Yeah. Why?
First thing is that 30
because the track is the planned track is 282.
Because the NDB is 30 nautical miles ahead of the aircraft.
Yeah.
Which means the aircraft is moving towards the NDB, and the towards on relatively on this track is somewhere on this side. That's why it's coming towards the NDB. But to place the aircraft, I cannot place it on this because of the planned track. I need the actual track to put the aircraft on. How will I find the actual track? To find the actual track, some information is given in the question. It is told that the aircraft is making good a track. What is it making good a track? Is a track made good? The actual track of the aircraft. The aircraft is making good a track 5 nautical miles left of center line. Let's see here, 5 nautical miles left of center line. The center line is defined by the NDB and parallel to it. So let's understand what these words are, the question. Now, what is this? This is a planned track. The planned track is defined by the NDB, and therefore this is the airway. This is the airway center line, defined by, this will be under NDB here, and that this is the planned track. Therefore, this is the actual airway, right? This is the airway center line, right? Now, where is the aircraft with respect to center line? The actual track of the aircraft is 5 nautical miles left of center line. And since we know that the aircraft is coming from here towards this side, then left is here. If you go wrong on this, your left will be on the other side. So be very careful, your track, everything will change. Therefore, the aircraft is somewhere left of center line and flying a track that is parallel to it, which means the aircraft is coming somewhere from the left, flying a track that is parallel to the center line of the airway. Right? Until it is 30 nautical miles from the NDB. So you can see once the aircraft is here, the NDB is 30 nautical miles ahead of the aircraft. Right? So this is the actual track of the aircraft. The actual track of the aircraft is 5 nautical miles left of the center line. This is the center line of the airway and parallel to it. Right? Now what is given in the question? The aircraft is flying a heading, which we know, 12 degrees starboard pitch, making good a track of 5 nautical miles left of center line of the airway but parallel to it. Understood that statement? Left of center line and parallel to it. Now what is given? Find the relative bearing of the NDB situated at center line of the airway. We know that the NDB is situated at the center line of the airway. Right? You're asked to find out the relative bearing of this NDB when the NDB is 30 nautical miles from the aircraft. So let's draw the aircraft. The aircraft is right here. To draw the aircraft, I need the heading. What is the heading of the aircraft? We have assumed the heading here. Heading of the aircraft is 270, right? So 270 is exactly in this direction. Heading is 270 degrees. Now, you're asked to find out the ADS indication. Read the question. Find the relative bearing of the NDB situated at the center line of the airway, 30 nautical miles ahead. So, you have actually tuned into the NDB, and when once you tune into the NDB, what happens? The ADS is simply going to show you, the needle is simply going to show you where the NDB is. You're asked to find out that indication, that's all. So, basically, what is the head of the RBI?
0.
You basically have to find out this angle, that's all. And that is going to be the indication here. If it is 10 degrees, it's 10 degrees, 20 degrees, 20 degrees. How will you find this angle? It's a question. So look at the question again. The NDB is actually 30 nautical miles ahead of the aircraft, which means the aircraft is coming towards the NDB. We found out the planned track as 282 because we took and we assumed the heading and we applied planned drift and we got the planned track. Right? It says that the NDB is 5 nautical miles left of this planned track. Planned track defines the center line of the airway and 30 nautical, and it's also flying parallel to the planned track until 30 nautical miles. Now it has to track towards the NDB. Since it is tuned towards the NDB, the ADF is going to show exactly where the NDB is. We're asked to find out what this particular indication is. So we are trying to find out this angle basically. So as you said, you can extend this line. So what is this track? Since this track is parallel to this track, it is 282. So that will immediately give you this angle.
Yes.
270?
12 degrees.
Yeah. 12 degrees. Now the only work is to find out this angle here.
So by using the closing angle, we can find this
What's that?
particular
Now, if you can find out this angle, that is exactly this one. And how will you find the closing angle?
degrees. 5 nautical miles divided by the distance more to go.
Yeah, so this is 30 nautical miles. For smaller angles, you can take this also as
30 only.
30 nautical miles, right? So when you apply 160 here, closing angle is distance off by distance to go
Gone.
into 60. So what is distance off? Distance off is 5. Distance to go is 30
to 60.
into 60.
That is 10 degrees.
This 10 degrees. So we know that over 60 nautical miles, 5 for 5. So over 30 nautical miles, 5 for 10. This is going to be 10 degrees. This is 10, therefore this is 10. Therefore, what is the ADF going to indicate? Tracking towards the station is going to indicate 10 plus 12, which is
22 degrees.
22 degrees. Understanding the meaning of this question is a trickier part. So because they give all these things, 5 nautical mile left of center line, 30 nautical miles ahead, parallel to track. This is how the actual view is. And then, therefore, the answer is 22. Did you understand, Deepika, now? Better?
Yes, sir. Yes, sir.
Yeah?
Much easier.
Yes. Now, before you copy this thing down, let me tell you one more thing. As per the ICAO standards, which is International Civil Aviation Organization standard, an airway is to have a buffer of 5 nautical miles on either side. So if Dgca, if we establish an airway, like domestic airways, international airways here, which are regional, non-regional, RNAV routes, so many routes are there. So say for example, this is an airway, and the airway is to have a 5 nautical mile buffer on either side. This is the buffer on this side, 5 nautical miles on this side. There is an equally wide buffer on the other side. So every airway is to have a buffer like this. The next airway can come only after giving a 5 nautical mile buffer and the airway, and then its 5 nautical mile buffer. The buffers also should not coincide. That will actually allow, even if the aircraft goes off the airway, there's the probability of collision is actually kind of reduced. That's the whole idea there. Right? So you can see by giving 5 nautical mile buffer, 2 different airways would be always separated by 10 nautical miles. Because both of them have that 5 nautical mile buffer. So that is why we say that even though the aircraft is 5 nautical miles off center line, it is still considered to be within the airway. Right? So if you look at the question, aircraft is flying, a heading, everything is given, but left of center line of the airway and parallel to it. So it is still within the airway. So it's still within the limits, and now it is trying to track towards the ending. So you learn regulations, you learn this. An ICAO requirement is you have to have 10 nautical mile. When width of an airway should be 10 nautical mile. 5 nautical miles either side.